in that case, if we use the second point, we would get this. What we would get instead would be y minus 4, right? 4 is the y coordinate of the point. Y minus 4, 4 is the y coordinate of the point, equals 2, okay? The slope times x minus 2. 2 times x minus 2. 2 here is the x coordinate of the point. I mean, you really could use any point you want. The graph you get is going to be the same. That's what matters. I know from my experience teaching this course, students have trouble with this, the point slope form. I know they prefer the slope intercept form, which we'll see shortly, but I thought it would still be good to present this. So let's do an example or two. Let's say we wanted to sketch the graph, that is, excuse me, the line whose equation is this. This is actually point slope form. Okay? If you want to graph a line, you need 2 different points on a line, and then you just connect them. So we need 2 solutions to this equation, right? 2 solutions. So in this case, we could choose different x values, calculate the corresponding y values, kind of like when we were first graphing in the previous section. So for instance, if I take x to be 3, right? Then, I mean, the point on the line is 3, 1. I'm showing you y. If I take x to be 3, then y minus 1 in the equation, that's going to be 5 times 3 minus 3, which is 5 times 0, which is 0. So we get y minus 1 will be 0, but hopefully by now you can see that by just adding 1 to both sides, you get y has to equal to 1. So in other words, if x is 3, y equals 1 by direct calculation, and that shows you 3, 1 is a solution of this equation. So it's on the line. And we can do the same thing, and we have to do the same thing again, but with a different x. So for instance, I took x to be 4. But you could take x to be anything. You could do -4, you could do 0, or whatever you want. I took x to be 4. Well, then y minus 1 is going to be 5 times x, which is 4, minus 1. Which is, wait a minute. Oh, that should be a 3. That's what threw me off. I missed that. But basically what I get is, sorry about that, that should be a 3. My mistake. Basically here, hold on, how did I miss that? We get y minus 1 is 5 times 4 minus 3, right? And that's going to be just 5 times 1, which is 5. So y minus 1 is going to be 5, right? That's what we get. Okay, so just adding 1 to both sides, y has to be 6. And so from there, 4, 6 is also on the line. It's a solution of the equation. So we have 2 points. We plot them. Here's 4, 6. 3, 1 is here. And then you just connect. I used x equals 3 for the first point. I used x equals 4 for the second. Again, you can use any x values you want. You can use 0, you can use 1, you can use 2, whatever. As long as you get 2 separate points, you're good. Okay. Any questions on that? Let's do another one then. So this one's a little bit different. Here, we kind of go the opposite way. Namely, I give you the graph, but now we have to find an equation of it. So I give you the line. Okay. So here we need to get an equation of the line. What do we need? We need the slope, right? And we need any point on the line. I mean, really, to get the slope, you need two different points. So theoretically, you need at least two different points, which we have. Right? So we have 1, 2. That's 1 point on the line. Another point we can use is down here, -3, 0. Of course, there's other choices, right? Here it looks like we have -2, 1/2. Here it looks like we have -1, 1. Here's 0, 1.5. So that's what we get. So this is what we get here. So -3, 0, 1, 2. Let's use those 2 points. But really, any two different points on the line you can use. Okay. So we calculate the slope. Again, same idea. Let me get the pen out. Right? So we can do this from the second point to the first point. Right? 2 minus 0 over 1 minus, oh boy, negative, what is that? -3. So 2 minus 0 over 1 minus -3. Right? Change in y over corresponding change in x. And we get 2 over 4, which is 1/2. The slope had to be 1/2. Let me go back to the graph for a second. We got a positive slope. That's expected. And why is that? Well, if I were to move horizontally to the right, along the x-axis, right? What's happening then? The line is climbing. The line is climbing. It's moving up to the right. Okay? So that tells us right away we know the slope has to be positive. So if we messed up the calculation and got a negative number, then we know we did something wrong. So now we know the slope. An equation of the line then, using the first point, would be y minus the y coordinate equals the slope, 1/2, times x minus the x coordinate, -3. So we have y minus the y coordinate, which is 0 in this case. We're using the first point, equals 1/2 times x minus -3. Which you can better write as y equals 1/2 times x plus 3. Like so. Okay. Over here, right, for this equation, okay, for this equation, I'm using the second point. So in this case, the slope's the same. Y minus 2 is 1/2 times x minus the x coordinate, x minus 1. So that's what we get here. So we have this now. So again, they're both the same line. It's just that in this case, I use the first point. Here, I use the second point. Doesn't matter. I can really use any point I want. This is just saying here, if we got a negative number by messing up the calculation, we subtracted in the wrong order, in the top or the bottom, we would get a negative slope. But again, from the graph, that's impossible. I mean, even if you were to look at the points without the graph, right? We can see from here that if we let x go from -3 to 1, the points here are telling us that y goes from 0 to 2. So if we let x go from -3 to 1, the y values go from 0 to 2. So in other words, if you increase x, the y value also increases, the y coordinate. Hence, the slope is positive. So that's what we get here. All right, that's awesome. Any questions on this? Okay, let's do another one. Ugh. Actually, excuse me, not another one. Let's look at this now. Sorry, my mistake. Okay. We have now what's called the slope-intercept form. And basically there, it's actually a special case of the point-slope form. Here, the slope-intercept form of an equation of the line, which has slope m and y-intercept b. So in other words, the line has slope m, and it's passing through the y-axis at number b, whatever b is. An equation of that line is y equals mx plus b. It's actually what you get from point-slope form. The point you would be using would be 0, b.